Okay, part number 2 of our test review. Problem number 7. This one says list a tick mark using the roster method. And again, the tick mark means complement. So we want the complement of the elements in A. That means we want in our set A complement, we want all the elements that are not in A. Okay, so the ones in A are 3, 20, and 29. We want all the other ones to be in our set A complement. So A complement, we'll put our curly bracket here, and these don't have to be in any specific order. Okay, the order doesn't matter here, but I'm going to do the ones in B: 16, 32, 44, 48, and then the ones out in the universal set: 35, 36, 47, 52, and 54. So again, A complement, all the elements that are not in A. Okay, let's go to number 8. Alright, this looks like one of the really tricky ones that I did a video on already, but it's not as bad. Okay, it just looks the same. It says there are 38 students in the University Travel Club. The following information in Venn diagram show how many students travel to Germany, France, and Spain. But look at the question. It says how many students have been only to France. And it gives us this Venn diagram that's already mostly filled out, and maybe not completely, but mostly filled out. Okay, so we're trying to figure out how many students have been only to France. So only to France will be this part out here. Okay, so we got to figure out that last part of our France circle. Okay, let me get that out of the way. So it also tells us that a total of 18 students have visited France. Okay, so we can subtract to find this answer out. Okay, we got to have a total of 18 in the France circle. So we'll start out with 18, and then we got to subtract the 3 parts that are already in there. So minus 4, minus 3, minus 5, subtracting these because they're already in the France circle. So that leaves us with 6 out here. So how many students have only been to France? 6. Okay, so it's not as bad as the one we did before, and not quite as much work there. Okay, what about number 9? Let's see. Number 9, we don't have any calculations involved. It's really a vocabulary question. Okay, so it says, which of the following is not an example of a mathematical statement? Okay, so what types of statements are not mathematical statements? Well, if we have something that is an opinion, okay, then that's not going to be a mathematical statement. Or if we have a paradox, that's not going to be a mathematical statement. A mathematical statement is something that has a truth value. It is either true or false. So we're trying to find which of the following is not a mathematical statement. So let's look at A. It says the milk has no chocolate in it. Okay, well, that's either true or false. So that one is a mathematical statement. B says my boyfriend is taller than I am. That's either true or false. So that is a mathematical statement. C says don't get behind the wheel until you learn how to drive. Well, is that true or false? No, not really. That's kind of a command, right? That's telling us not to do something. Does it have a truth value? Let's check D. It says Michael Jordan's basketball jersey number was 11. Okay, that is either true or false. In this case, it's false if you know Michael Jordan's basketball jersey number. Okay, so the only one that is not necessarily true or false, the one that is not a mathematical statement, is C. Okay, so head to number 10 here. Okay. Number 10 tells us to use the letters given to express the given compound statement in symbolic form. And the statement that we're looking at is, I like green eggs and ham. We're trying to make that out of these two statements. Statement M says, I like green eggs. Statement N says, I like ham. One thing that might be a little tricky on this one, we can rewrite the sentence, I like green eggs and ham. We could say, instead, we could say, I like green eggs. And I like ham. Okay. I guess I should put my comma in there to make the English people happy. Okay, so we could rewrite it like that instead, and that's a little easier to put in symbolic form. So if we look at our first statement here, I like green eggs, well, that's statement M, so we would have M. Okay. Then we need something for and. Okay. So for and, our symbol looks like a triangle without a bottom. Okay, here an arrow pointing up, or a capital A without the bar in the middle. Okay, so that would be and then we need something for I like ham. Well, that is statement N. Okay, so in symbolic form, we would have this M and N would be our symbolic form of this statement. So that would be I like green eggs and I like ham, or another way of saying that, I like green eggs and ham. Okay. Number 11, we're going the other way. Okay. This one says use the given simple statements to write the compound statement A, and then we've got this V looking symbol, B in words. So the first thing we're going to need statement A, and it tells us statement A is it is hot. Okay, but then we got to know what this V symbol stands for. Okay, so in logic, that V symbol, okay, stands for or. Okay, so we'll have it is hot, or then we need statement B, and statement B is, let me scoot that over a little bit, the ice cream is melting. Okay, so the it is hot part is statement A, or our little V symbol here, and then the ice cream is melting, that's statement B. So we've gone from symbols into words. One more in this video, do number 12. Okay. So this one says complete the truth table for the following expression, and we got squiggle, W, V, symbol, Z. Okay. So that is the negation of W or Z. Okay. So we're doing our truth tables here, and you just want to do these, you just want to do them one column at a time. Sometimes people try to do them a row at a time, and that gets kind of confusing. So let's look at this one column at a time. So first, okay, it gives us the columns for W and Z. Okay, get this started out there. And then the next column we want to fill out is this squiggle W, or this negation of W column. Okay. So if we're negating W, what does negation mean? That just means that we want to take the opposite of what W was. So here W was true, so for the opposite of that, it's going to be false. On the second row, W was true, so it's false again. On the third one, W was false, so this time it's going to be true. And then on the last one, W was false, so now it's going to be true. Okay, so we've got that column filled out. Now for the last column, it says we want to look at the negation of W and the Z column, and we want to join those together with or. Okay? So our rule for joining these things with an or statement is that if either one is true, our answer that we write down is going to be true. But if they're both false, the answer we write down is going to be false. Okay, and what columns are we looking at? Let me get these out of the way. Okay, what columns are we looking at? We're looking at the column negation of W, and we're looking at Z. So now those are the only two columns we're having to look at here. Okay, so what are we going to get? So if we've got a true and a false on the first column, and if you want to do it in the order, you can say false and true. Okay, so if either one of those is true, our answer is going to be true. Well, since Z is true, it makes this one true. Okay. We go to the second row, we look at Z, it's false. Negation of W is false. They're both false, so that means our OR statement is going to be false. Okay. We go to the third one, we've got true, true. Well, they're both true, so that means at least one of them is true, so that one's true. And then on the bottom row, we've got false, true. Well, one of them is true, so with an OR statement, that means the whole thing is true. So we end up with true, false, true, true. The only time an OR statement is false, like this one, is if both of the statements going in to make that compound statement are false.